Because SQL is designed to work with data, there are several functions and capabilities for aggregating data. New to SQL Server 2005 is a whole set of windowing functions. Since AdventureWorks has some large tables, I want to show you the windowing functions from AdventureWorks. So switch to AdventureWorks database. Just to check the data. Sure enough, this table has 113,000 rows. It's a great table for some of these windowing functions to show you. New to SQL Server 2005 is the row number function. It's not very intuitive, so let me walk you through it. It's row number function, and then you have to say over, and some particular way that we're going to sort to provide the row number. Then this is just the standard alias that I'm using. So to run this and see some row numbers. Now, right away, you're going to probably think that the row number would be great to restrict rows, to work with batches of rows. And this is the first syntax I tried when I started playing with row number. And it fails, because the row number or the over function, the windowing function, can really happen only in the selector order by clause. The workaround for that is to use a subquery. Everything builds upon itself in SQL, so in this lesson we use subqueries extensively. So this is a simple subquery. We see product ID, transaction date, there's the row number. Now that we have row number in a data set, we can then select off of it. So the outer query is able to select row number 10,001 to 20,000. And bang, there we are. Works great. And this little commented out portion of the where clause uses the modulo function to divide it by 5 and look at the remainder. And if there is no remainder, then it must be every fifth row. So a pretty slick way of batching together your rows. This is useful because we used to have only a choice of either set-based to handle all the rows to be updated, for example, in one large set, or a cursor to go through one single row at a time. And for some problems, both extremes were inadequate. So I love this new feature. There's a number of other ranking functions that also work with this over windowing function, besides row number. There's rank, dense rank, n-tile, you have to supply a number for n-tile, and then rank with a partition. The best way to show you this is just to run it and let you see what it does. Here's row number that we saw before. Here's rank and dense rank. Similar to the top with ties, this shows us 1, 2, 3, 4. This is the 5th position, and so on. However, dense rank will say these are all tied in first place, then these would all be tied in second place. The n-tile takes the entire data set and simply spreads across whatever you're saying. This is we're saying 1 through 5, spreads 1 through 5 across the whole data set. Because of the sort right here, it shows out a little bit differently. And then ranking over a partition will take the rank and group it by territory ID in this particular case. So it's pretty powerful. Let me focus in on the n-tile just to show you that. Percentile ranking, and if you forget about percentiles, think about how you were scored back in school. Maybe the ACT test gave you a percentile. It's where one particular item falls in over a percentile of all the items. So this example isn't very meaningful because we're just using customer ID, but you could see where it could be a very powerful tool for reporting, just to go ahead and produce a percentile over all the data. Working with groups of data, working with aggregates, we also typically have to see sample data. A common solution for finding sample data or random data is to select top 1 or top 10, something like that, and then say order by the new ID function, which generates a GUID that will randomly return a row. But it's very slow over a very large data set. So the table sample is a new option to the from clause, which actually randomly chooses data pages. So in this example, we're looking at the sales order header table and selecting 10,000 rows. But what's really going to happen here is that SQL Server will say, for 10,000 rows, I probably need, about 3 data pages, as my guess, and it'll then return all the data from the 3 data pages. And if you watch down here in the lower right-hand corner the number of rows returned, I'll execute this several times and you'll see that when it randomly selects those pages, we get back different numbers. So there's 8,000 rows, 5,000, 13,000, 10,000, 11,000. This is not a bug at all, because we're not saying we want exactly 10,000 rows. We're not saying top 10,000. We're saying table sample about 10,000 rows, and it's going to go get the data pages for those 10,000 rows. Then there's also a % variation of the same function.